proceed. All right, now we go on to circles and graphs. Given an equation, y equals f of x, where y is dependent upon the variable y depends upon the variable x via the function f. This equation has a graph. It's a set of all points x by f of x in the Cartesian plane. For example, the equation y equals x squared. Well, we can find some specific values. Oh yes, the other day I made a big flub, didn't I? I had a 2 here where it should have been a 1. You can see I corrected it, and it's even a little darker from the correction. Anyhow, when you let x go through, here are 5 values, but of course there are infinitely many possible values. -2, -1, 0, 1, 2 square, you get 4, 1, 0, 1, 4. Here's the point -2 by 4. Here's the point -1 by 1. Here's the point 0 by 0. Here's 1 by 1. Here's 2 by 4. 5 points. And of course, there's here be -1/2 by 1/4. Here's +1/2 by 1/4. Here'd be 3/2 by 9/4. There is infinitely many points to plot. Okay, here I plot only 5 of them or whatever, and you join them up in a curve. This U-shaped curve called a parabola. I believe I mentioned the other day that this is the curve that something in free fall might fly through the air, or it's the cross section of a radio telescope or radio antenna, because parabolic mirrors turn parallel beams of light of radio waves and gathers them at a focus point, whatever. Here's an equation 2x plus 3y = 6. This sort of equation is known as a linear equation. Ax plus by = c for a, b, and c constant. It will draw a graph as a line in the plane. This point here is the x-intercept, where y is 0 and x is whatever it is. This point here is the y-intercept, where x is 0 and y is whatever it is. Now, okay, a table, therefore all you need are 2 points to plot a line. When x is 0, you plug in 0 in here, you get 3y = 6, therefore y = 2. If you substitute y = 0 in this equation, you get 2x = 6 or x = 3. So the point 0 by 2 is on the graph, and the point 3 by 0 is on the graph. This is a linear equation, so the graph is the straight line between these 2 points. Now, okay, later, and we do a lot of graphing of trig functions, we'll be dealing with the symmetries of the plane. Symmetrical left through right, flip to the y-axis. Symmetrical up through down, flip to the x-axis. And symmetrical around the origin, rotate around the origin. If a point is x by y, when you flip it through the y-axis, you get the point -x by y. X by y, when flipped through the x-axis, gets the point x by -y. And x by y rotated halfway around the origin gets to the point -x by -y. So if you flip through the y-axis, then let's try this again. If you flip something through the x-axis and then through the y-axis, that's the same thing as a 180-degree turn. So, for example, find a point symmetric to this through x-axis, y-axis, and origin. -2 by 1 to the x-axis, you change the y value, so -2 by -1. Flip to the y-axis, we flip x value, you get 2 by 1. Symmetric through around the origin, you change both their signs and get 2 by -1. -3 by -4. Flip through x-axis is -3 by +4. This flip through y-axis is +3 by -4. This flip through the origin is 3 by 4. Now, okay, not only can points be symmetrical through the axes and the origin, so can a graph. Here's a graph, which is symmetrical through the x-axis. Any point x by y on here, there will be another point x by -y also on this. This graph is symmetrical through the y-axis. So if x by y is on the graph, so is -x by y. This graph is symmetrical around the origin. So if x by y is on the origin, so is -x by -y. When you have a graph, it will intercept the x-axis here at the x-intercepts. These are points where y = 0 and x is whatever it is. This is the y-intercept, where it meets the x equals 0 axis, the y-axis, and y is whatever it is. For example, here's a graph. It has an x-intercept at -4, -2, +2, and +4. It has a y-intercept at y equals 2. Since we've been doing trigonometry is very closely related to circles, we have to know about the equations of circles in the Cartesian plane. So given a Cartesian plane and a circle with a certain center, let's say h by k, and a certain radius, say r. So given h by k center and radius r, what are the coordinates of a point x by y on the circle? Well, x by y is at a distance r from h by k. So x, y, h, k distance is r. And so the distance is square root of sum of squares of differences. X minus h squared plus y minus k squared, all square root, equals r. And then squaring both sides, we get this equation. X minus h all squared plus y minus k all squared equals r squared. That is the equation of a circle with center h by k and radius r. For example, say the center is -2 by 7 and radius is 5. What's the equation? Okay, it'll be x minus -2 all squared plus y minus 7 all squared equals 5 squared. Okay, minus and negative cancel, so this will be x plus 2 all squared. This is y minus that plus y minus 7 all squared equals 25, and this is an equation of the circle. Just a second, we have a few. All right, so examples. Write equations for the circle with center 4 by -3 and radius 5. They'll be what will be called the standard form and the general form. Okay, 4 by -3. So x minus 4 all squared plus y minus -3 all squared equals 5 squared. Okay, minus a negative is plus. X minus 4 squared plus y plus 3 squared equals 25. This is a standard form. You can read off the vertex, the center, and the radius. You have to take the square root to get the radius. Now, however, sometimes you go a little further by expanding this and combining terms and canceling, and we get this. X squared minus 8x plus y squared plus 6y equals 0. This is a general form. Ax squared plus bx plus c plus dx squared plus ay squared plus ey plus f equals k. Whatever. So you start with a standard form and expand it, and that's the general form. What center, radius, and intercepts for the circle with equation twice x minus 3 squared plus y squared equals 8? Well, first, there's these two that are in the way. Let's get rid of them by dividing throughout by 2. So this divide this term by 2, and this term by 2, and this term by 2. Then x minus 3 squared plus y squared equals 4, which is 2 squared. So the center is 3, x minus 3, so put a 3 here. This is really y minus 0, so the center has y equals 0, so its center is 3 by 0. 4 is 2 squared, so the radius is 2. To find intercepts, well, to find the y-intercept, we set x equal to 0 here. Plug it in and get 9 plus y squared equals 4. There's no real solution. There's no real y-intercept. It does not, the circle does not meet the y-axis. To find the x-intercept, we set y equal to 0 in here. Get x minus 3 squared equals 2 squared. So x minus 3 is plus or minus 2. Transpose the 3. X is 3 plus 2 or 5, or 3 minus 2 or 1. X is 5 or x is 1. Those are the x-intercepts. Here, find the equation of a circle with a diameter ending at -3 by 2 and 1 by 4. Now, all right. The center will be the midpoint of those 2 points. So, okay, take the average. 1 plus -3 over 2, 4 plus 2 over 2. -1 by 3 is the center. So, okay, we're halfway there. To find the radius, let's take the distance between 1 by 4 and -1 by 3. Square root of sum of squares of 1 minus -1 squared plus 4 minus 3 squared. This will be 2 squared plus 1 squared, 4 plus 1, 5, take the square root. So the equation is x minus -1 plus y minus 3 equals root 5 squared. Remember, this is r, root 5. What we need here is an r squared. People sometimes get those confused. So, okay, after a bit of simplifying, x plus 1 squared plus y minus 3 squared equals 5 is the equation of the circle. This one, I think the book, well, I think this is one of these ones where it's a bit of geometric intuition is a nice shortcut. Here we have a circle with the equation x squared plus y squared equals 9. I have a square inscribed within it. What is its area? Okay, x squared plus 9 squared equals 9, which is 3 squared. So this circle has radius 3. So we draw these 3 diagonals. And okay, the way I do it is geometric and breaking up. We take this square and we break it up into these 4 triangles, and then we reassemble them into these 2 squares. There are 2 squares with side 3. So the area is twice 3 squared, which is twice 9, is 18. You can also figure out the length of this, which will be 3 root 2. That squared is 18. I think this is actually a little easier to understand. Okay, I think that's it for now. Stop recording.